One reason why Kotlin gained popularity very quickly over Java is the way that Kotlin handles nullability. In this video, I'm going to explain a little bit about nullability and what it is, and give a live demo. So first of all, what is nullability? Nullability is when you have a variable and you don't have an object inside of it. So remember that when we create a variable, we'll typically declare the variable and then we'll assign an object to it. We can do that all at once. That first time we assign a variable is called initialization, or we can do it in two separate steps where we declare the variable and then we assign it later. The risk of declaring the variable and assigning it later is that for a time, that variable has no object inside of it, and it's essentially null. So if you were to try to invoke a function or a method on that variable, you would get a null pointer exception traditionally in Java. In Kotlin, there are some other ways that we can handle this to avoid the null pointer exception. So what is a null pointer exception and what is a variable that's null versus a variable with an object? Well, that's best explained through analogy. A good analogy for a null pointer exception is a parking space. So a parking space can hold exactly one vehicle. And if I have a vehicle in the parking space, I can do things like unlock the vehicle. I can open the door to the vehicle, shut the door to the vehicle, lock the vehicle, and do other operations I could normally do with the vehicle. That's what happens when a variable contains an object. But what if a variable does not contain an object? Let's consider this space, 639. There is no vehicle here. Therefore, there's no door for me to unlock. There's no door for me to open. It's simply empty. If I were to try to unlock the vehicle, start the vehicle, and there's no vehicle here, that would throw a null pointer exception. Let's consider some of the unique ways that Kotlin handles nulls. In Kotlin, we can declare variables one of two different ways. We can declare it as a nullable type, which is what you see here, which is where we have the data type and then a question mark, which means we can assign null to it. The other way we can do it is the variable type without a question mark, which means it is not a nullable type. That means we cannot assign null to it. And if we try to assign null to that variable, we will get a compiler error. Now, a compiler error is much better than a runtime error. A runtime error would be like a null pointer exception, because the null pointer exception happens when the program is running, and that's going to frustrate the user. Where a compiler error happens when we're writing the code, so we have time to catch it and fix it before it becomes a problem that the user will see. So let's go with the first definition where we have specimen as a nullable type. And let's consider the following possibility. If I try to invoke a function on a variable that does not contain an object, so in other words, a null variable, the default behavior for Kotlin is simply to return null or propagate null back in lieu of throwing a null pointer exception. Now, there are some times where you will have a nullable type, like the first line of specimen I have here, and then you're going to want to call a function that accepts a function, but that function signature may not have a nullable specimen type. In other words, you're dealing with this variable here, which is nullable. You want to pass it into a function that is set up with specimen without the question mark, which means it can't be nullable. So to convert from a nullable type to a non-nullable type, I'm going to borrow a phrase from our friends over on iOS, which is force unwrap. And that's where we put two exclamations after the nullable type. And we basically say, I am asserting that this is not null. As a developer, I'm asserting that this is not null. Now, the risk is, if it actually is null, what happens in this case? You will get a null pointer exception. And that is one way to get a null pointer exception in Kotlin, is to use a force unwrap on a variable that does not contain an object and then try to call a function on it. So we want to avoid that. That force unwrap is really not a good idea. So we want to think of some other ways that we can handle this. Now, one popular way is to use a scoped function, and specifically the let scoped function. A scoped function means it's running within the scope or within the context of a specific object. And here we're saying that we're running this on the specimen object. Once again, or the specimen variable in this case. Once again, this is the nullable specimen variable, and we're assuming that this variable does not contain an object, so essentially it is null. Now remember, what did I say would happen in this first option if we try to call a function on a variable, and that variable contains null. Well, Kotlin simply cascades back the null. It doesn't even run the function because there's nothing to run the function on. So specimen.let here, this third line right here, is null safe. In other words, it's only going to run this lambda that follows the let if the variable specimen contains an object. Now, what if it doesn't contain an object? What happens? Well, that's where we can use this thing called the elivs operator. In Kotlin, the elivs operator is a question mark colon, and it will follow the case where we have a nullable variable, and then we're invoking a function on that nullable variable. And what that does is give Kotlin another option instead of simply propagating back null or cascading back null. What it will do is say, hey, if you're trying to run a function on a variable that is null, do this instead. And the do this instead part is whatever follows that elivs operator. I'll have a code demonstration in just a moment that hopefully will make that a bit more clear. But first, let's explore a little bit more about this let scoped function. And this is really a good look at Kotlin and the inner workings of Kotlin, especially if you're used to another programming language like Java. So what is let? Well, it's a high order function. And a high order function means it's a function that can accept other functions as a parameter. Now, there's a secret in Kotlin that I didn't know about for a long time, but it's a really good secret. If you have a high order function, and you are passing a function into that high order function, specifically a lambda, and that lambda you're passing happens to be the last parameter you're passing in, you don't actually have to pass it within the parentheses that define that function call. You can put it after the parentheses, and if it's the only thing you're passing in, you don't need the parentheses at all. I think this is best explained if we look at a few different ways that we can do this. So we see that specimen.let open and close curly, that's essentially a lambda we're passing to the let function. We could also do it like so. We could call the let function with an open and close parenthesis, as we would call any other function, pass no arguments in, and then pass the lambda next. Because we know this bolded Kotlin shortcut, we can pass the lambda after the function call if it is the last parameter we're passing. Now, we don't have to, right? We could still pass it in directly to the function, right? So we could take that lambda and we could pass it in within these parentheses if we want. Or another way we could do it is in Kotlin, we can assign a lambda or a function to a variable. So you see here, I'm making essentially a little lambda with nothing in it, but I'm assigning it to the variable my function, and then I'm passing that my function variable into the let function. Now, all of these are equivalent. Everything that you see here is equivalent, just different ways of doing the same thing. But hopefully when you see this, you can see that let is actually a function that we're invoking on this variable called specimen here. And then that takes us back to our other rules where if we're invoking a function on a variable and that variable is null, Kotlin will skip that function entirely and either propagate back null or send back whatever follows the elivs operator. So with all of that as a context, let's take a look at a demonstration in code. I've created a simple test class that covers a lot of those examples that I just showed. So first of all, we have a specimen nullable type. I've assigned null to it. I've essentially put nothing in it. And then I'm going to call toString. Let's see what happens when I call toString. Note that we do not get a null pointer exception as we typically would in Java, but take a look at what's in this specimen string. Null. So it simply propagated back null. No harm, no error, just propagated back null. Now let's try a force unwrap. To make this one a bit more visible, I wrapped it in a try catch with a null pointer exception so we can see the null get caught. So the first line we do is we run a toString on this specimen object, or specimen variable rather, which contains no object. As a matter of fact, let's see if we can mouse over this. It's null. So you can see from the debugger here, it's null. So what happens when we try to do a force unwrap? I press F8, and where do we go? We go straight down to the catch block. We skip line 30 because it has thrown a null pointer exception. And in the land of Java, that's what we would expect to see. Now let's take a look at handling null with the let function we talked about just a moment ago. So specimen is still null. I press F8, and notice that it completely skips line 39, which is the logic within the lambda that we're passing to let. But notice it's on the elivs operator now, and I press F8 again. And what's in specimen string? Notice specimen is null. And where did that come from? That came after the elivs operator, because it said, well, it's null, so it's null. Now let's take a look at actually creating a non-nullable object with let. And once again, similar breakpoints. What you see here is I'm declaring a specimen object, and I'm storing that in this specimen variable. These tests I'm all running in isolation, so one doesn't impact another. Ah, look at that. You notice that it jumped right into our lambda. It's on line 48 now because it knows that specimen is not null. And it's going to skip the elivs operator. In specimen string is going to be eastern redbud, which is the plant name that I have passed into this specimen. Now, I hope that was a lot of fun, but I do want to get into a bit of further reading if you're interested. I talked about how that let function works and how that works with Kotlin, with passing in a lambda, making it the last argument. So I did one final demonstration where we can take a look at how we can use let, and we can validate that it is a legitimate function just like toString would be. So our final test. Take a look at line 55, and you notice that I am declaring a variable called myFunction. I'm giving it an incoming type of specimen, which is what we're calling on our let, and an outgoing type of string. And then I simply say invoke specimen toString. In other words, this is exactly the same as what we saw up above, where we are simply invoking specimen toString. It is this exact lambda right here that I've highlighted, but you notice, same, just like that. I'm simply assigning it to a variable. So we assigned a variable, and we go ahead and instantiate a specimen. We put a legitimate object in there. Now look at line number 60. You see in line number 60, we have a little different construction of let that we're not used to. We have parentheses, not curlies, because here what we're doing is we are taking a function we've assigned to a variable, we're passing that variable into let and saying, here's the lambda I want you to run. After that, we have the elivs operator. We have specimen is null. Actually, might be kind of fun to go ahead and snap a breakpoint there. And let's go ahead and do a function F8. Where does it go when I do that function F8? It goes right into this lambda I've assigned to a variable that I've passed into the function called let. So you see how high order functions work. We're passing a function into a function, and we're telling that function to run the function. That probably sounded confusing, didn't it? But hopefully it makes sense. And we can assert not null. Again, we know we're good. Now, here's another option I tried. So we go ahead and we instantiate the specimen. Notice this let operation. I have open paren, and then open curly, close curly, and then close paren, and then elivs operator. Once again, all of these are identical. These are the same as the let operations I did up above. I'm just showing how we can invoke let as a function. And in this case, what I'm doing is I'm calling the function because I have the parentheses. But within that, I'm simply defining the lambda in line, which is common in Kotlin. You'll see this construction a lot where you see a function call, then within the function call you see the curlies, and you say, oh, okay, this is a lambda that's getting passed in as a higher order function. So let's see what happens this time. F8. And F8, and I didn't put a breakpoint within that lambda, but nonetheless we can still see that specimen string indeed is not null. It is eastern redbud because that is what I have passed into this object. So in this video we took a deep dive look at how Kotlin handles nulls without having null pointer exceptions, or in other words how it avoids null pointer exceptions. And we looked at several different ways that we can handle nullability in Kotlin, and then we took a look at some demonstrations to help visualize that point. This is one of the most fundamental concepts in Kotlin, all the things that I've described here. If you are going to a tech screen or interviewing for a Kotlin-based development job, I will bet you that some of these questions will come up, or this will help you to answer some questions. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.